Hello students, this video lecture for the first year BSc students which is studied physics in semester 1. In physics there are two papers, paper 1 and paper 2. I am going to present paper 2, that is physics principles and applications, and paper 2 I am going to discuss in this video lecture lasers and laser application. The syllabus is included by the Savitribai Phule Pune University Pune. Myself Dr. Madhav Sarodey, Registration Samstha Mahatma Phule Mahavidyalay Pimpri. The second chapter, lasers and laser applications. The outcomes of these chapters after studying these, so we can understand or we can define what is laser and what are the types of the lasers or what are the principles of the laser, then the different applications of these lasers just like in medicine, etc. So after completing this chapter, lasers and laser application, so let us see the first introduction about the lasers. We know that the laser stands for light amplification by stimulated emission of radiation. A laser is the mitre never avatar of light. This wonder beam has penetrated into normal life more than any of form of concentrated energy. Today, the word laser is familiar to everyone due to various applications in medicine, communication, industries, or in defense also. We understand the world around us with the help of information sensed by our five organs, namely eyes, ears, nose, tongue, and skin. The sense associated with eye is known as the vision or sight. Light is the agent which stimulate our sense of sight. The eyes convert the incoming light into electrical signals and convey from to brain. Brain process the signal, causing images or pictures to be created in our mind. So let us we study about the brief history of the laser. So lasers have truly been the one of greatest invention in 20th century. In 1970, Albert Einstein established the existence of stimulated emission in black body radiation. The laser beam was invented by physicist the Dioro man in 1960. The laser stands for L for light amplification, A for amplification, S for stimulated, E for emission, and R for radiation. So laser stands for light amplification by stimulated emission of radiation. They have found a variety of uses in electronics, computer hardware, medicine, industry, communication, or defense, that is military and experimental science. Laser is a device that emits the light through a process of optical applications based on the stimulated emission of electromagnetic radiation. A laser differ from other sources of light through a process. It emits light coherently. In coherent beam of electromagnetic energy, all the waves have the same frequency and phases. So then, what are the basic principles of the lasers? The principle of lasers is based on the three separate futures, means there are basically divided in three processes. These three processes respectively. The first one, absorption of radiation, or is also known as stimulated absorption. The second one, that is spontaneous emission of radiation. And the third basic principle of this process is a stimulated emission of radiation. So one by one we study in details about the basic principle of lasers. The first one, absorption of radiation or stimulated absorption. In this stimulated or absorption, let us see from this figure. You try to understand how we get the laser principles of this process. The first one, that is absorption, stimulated absorption. So in this diagram, an atom in generally remains in the lower energy state. Okay, when an atom is imparted some energy from outside, from this outside, it may get excited to the upper energy state by absorbing the photons. Means, see, what we say, an atom in general remains in the lower energy state is this one. When an atom is imparted some energy from the outside, and it may get excited to the upper energy state by absorbing the photons. Since the photons stimulate the atoms to absorb the energy, this is called the stimulated absorption. This energy will be absorbed, the electrons absorbing this photon energy. So consider two energy levels of an atom. Suppose initially the atom is in energy E1. This atom needs an amount E2 minus E1, that is the photon energy h nu, of this energy to go to the higher energy state, that is E2. And we know that the lower energy state is nothing but the ground state, and the higher energy state is nothing but excited state is this one. Then if mu with the frequency of absorbed radiation, then the photon energy h nu is equal to E2 minus E1, where h is the Planck constants. And in this process, the incident photon is lost by absorption, and the atom makes a transition to the upper energy state. Means during the absorption at the ground state, this atom will be, it goes in the excited state after the absorption. Photon energy absorb, and then we go to the higher energy state, that is the excited state is this one. Means the probability of the stimulated absorption depends on the property of the two energy state between which the transition is takes place. The probability of stimulated absorption depends on what? The property of the two energy state between which the transition takes place. Corresponding to each absorption transition, one photon disappears from the incident light and one atom is added to the excited state is this E2, and this process may be expressed as, means let me say, suppose A will be the atom in the lower state, lower energy state E1, and A star suppose in the atom in excited energy state A2 is this. So this can be expressed, that is what, A plus h nu implies to A star is this one, where A is nothing but what, that is the atom in lower energy state, and A star is nothing but atom in excited energy state, that is E2 is this one. So this is the process absorption, means absorption transition, one photon is disappears and incident light one atom is added to the excited state E2, and this process is nothing but that is the absorption. After the absorption, so we get then the number of atoms per unit volume that makes upward transition from the lower level E1 per second is called the rate of absorption transition, and it is given by the R absorption minus dN1 upon D2 is this one, where N1 is nothing that is the number of atoms per unit volume, and that makes in upward transition from this lower level energy to the upper level energy E2, and this is known as the rate of absorption transition, and this rate of absorption transition can be expressed that is minus dN1 upon dt, where this dN1 upon dt is represent the rate of population at lower energy, but this rate of population at lower energy is nothing but goes on decreasing. The negative sign indicates that the rate of decrease of the population at lower energy level E1, and the rate of absorption transition can also be represent the rate of increase the population at upper energy level E2, and this rate of absorption can be expressed that is R absorption is equal to dN2 by dt is this one, this expression that is dN2 by dt is this one, when the rate of absorption can be represented due to this increase the population at the upper energy level is this E2 is this one, and that's why the sign is what, the plus is this one, or we can say that this rate of absorption transitions is nothing but minus dN1 by dt, or that's equal to dN2 by dt is this one, means the number of absorption transition occurring in the material at any instant will be proportional to the absorption population in lower level N1 and the number of photons per in volume in incident beam, that is rho of V. Hence the rate can be determined with help of this, and that expression for the rate of absorption can be written or is directly proportional to the population energy level. Then this R absorption is equal to B12 rho mu into N1, and this B12 is nothing but that is the proportional constant. R12 is nothing but this is the constant of proportionality, and which is also known as Einstein coefficient for induced absorption, and rho V we know that this is the incident beam, means the number of photons per in volume in incident beam, and N1 is nothing but that is the population in lower level. Okay, so this B12 is nothing but that is the constant proportionality, and which is also known as Einstein coefficient for absorption. It represents what he represents, so it represents the probability of transition from state E1 to E2. In case of this, at thermal equilibrium, the population in the lower state is very large as compared to the higher energy state. Therefore, as light propagates through the medium, it gets absorbed. So this is nothing but the first process of the principle of lasers, that is absorption, or that is called the stimulated absorption is this one. Okay.